Hello all, I'm Mithun and welcome back to a brand new video. So in this video, we are going to look into a lot of things related to Docker. So the idea of this video is to give you a kickstart or that you understand the basics of Docker and start working with Docker. So that's the main agenda. Again, previous to this video, so we have also have a video on getting started with AWS where we have set up our AWS environment and we spinned up a virtual machine. So I would recommend you watching that video before starting this so that you can also be a part of this hands-on demo. Okay, so telling that, let's first start with what we are going to do in this video. We are going to first see why should one use Docker. There are a lot of questions. I will try to answer all of that one by one, and then we'll look into the concept of virtualization because I strongly believe that before understanding containerization, you should understand virtualization. We will do that, and then we'll next move to containerization, and then many a times people will equate containerization with Docker, and let me make that statement clear: both are not same. So it's one of the way Docker is a tool. So we'll describe Docker then and see how Docker does it, and some of the basic things you should have on top of your mind whenever someone is discussing about Docker. There is Docker images, containers, and the registry. We'll see that, and then finally we'll go to our EC2 instance machine, what we have spinned up, and install Docker there and run our hello world process or a container. Okay, so this is the whole idea of this particular video. Now, first question comes, Mithun, why should we use Docker? What's the problem? So let's understand the problem first. Now, like let's say you are building a project. So it might be any project. I am not going to just restrict to any one type of project. It can be a web project, AI/ML project. It might be a app project. Okay. So any of the project you build. So like let's take a project. So it will have multiple parts, right? Like let's take a web-based project. So it will have something like a runtime. You need Node.js, something like this, or else you need Python, you need Java. So something like that, you need something to run on. And then you will have your source code. Okay, you will have your source code. Next, you will have a lot of dependencies on it. Like you install a lot of packages and have a lot of dependencies, right? So dependencies, packages, environment variables, environments, something like this, environment variables, all of this, the configurations. So this is what a typical project looks like, irrespective of what project it is. So this is the basic structure. Now, the problem is like whenever you're working in a team, okay, or you're working on an open source project, or you're working among a enterprise team, or you want to just share the project and someone wants to run your project. Okay, so the first challenge is in the sharing part. When you're sharing something, okay, now if they have identical machines, then it might not be that much of a problem. It's not like they won't be, there will be problems. So like let's take an example. I installed and I built this project on Mac, and my friend is using a Windows machine or a Linux machine. So then the installations are completely different. Okay, the packages might support, might not support. Okay, so there will be a lot of issues. Okay, so this is one of the problems, right? Whenever I am sharing, you might have heard this. So they will be like, it's not working on my machine, and you will be like, it works on my machine. So this is the typical scenario where sharing is a hassle, especially with projects. Next, the same with deployments. Okay, now what happens is that whenever you're deploying the project, it doesn't happen manually every time. It will happen through continuous integration and continuous deployment, CI/CD, you would have heard of, right? So there also we face same issues. Okay, we need to automate stuff, and doing everything manually will not be the right thing. Okay, so these are the two problems. When we are sharing a project or deploying a project, we'll face some issues. Okay, remember this, these are the problems. Now, before directly entering into the world of containerization, so let's look into what virtualization is. Again, if you don't know anything, don't worry at all. So we'll take it everything from scratch. Now, typically what happens is that any machine, okay, so any virtual machine, anything, so you need a host. First you need a host machine. What it is a hardware. It is a hardware. It can be your computer, it can be a remote machine, it can be a server, it can be your workstation, anything. Okay, you need a physical hardware to run anything or to do any compute task, right? Again, just because you are running a instance on AWS doesn't mean that there is no hardware. There should be an hardware, and hardware will have multiple components, right? So it will have the CPU, it will have the memory, it will have the hard disk. Okay, so let me just pull this up. So it will have the CPU, it will have the memory. Okay, so it will have the hard disk, so it has a lot of components. Now in virtualization, what we do is that we will take this host machine and we will allocate some parts. Okay, like let's say some parts. Okay, so this is a virtual machine. So what it is, it's a part of the host machine. So we call this as a virtual machine. Okay, so it shares the resources. See, it has dedicated resource allotted. Okay, the main thing is that so it will have its own dedicated kernel. Okay, so it will have its own resources, it can have its own operating system. It's like a whole new machine, but only thing is that it's consuming the capabilities of it. Now who maintains this? So there will be a software called as hypervisor. Okay, there will be a program called as hypervisor who does all of this provisioning task, who creates a virtual machine, who allocates this, who deletes this, who manages this. Everything is a hypervisor. Again, you would have heard of VMware, right? So VMware is a very famous hypervisor. Okay, so this is what is a virtual machine. Again, you can have as many virtual machines as you want, but everything will consume the resources and each one will have a lot of kernel. Okay, let me give you in my experience, whenever you want to run a simple node.js project, you need to install node.js completely here. And any node project, if it's running on a VM, it would be around 400 mbps, the 400 mb. Okay, the minimal the package size. Okay, so because it installs everything, it needs its own OS, everything, so it is very much heavyweight. It is good, it gives you all of the capabilities, but it is very much heavier. Okay, so many a times whenever you do, right, so a whole project or the product will not be deployed on a VM. So a VM will be there, inside that there will be containers running. Okay, now like let's look into what is containerization. Now I think you guys have an idea of virtualization. Virtualization is like dividing the host machine using hypervisor, and it has everything of its own, including the OS, kernel, everything, but it is heavyweight in nature. Now like let's say I want uh, just a project to run which doesn't consumes a lot of memory. Okay, so how to do that? Okay, so to solve that, the concept of containerization came into picture. Again, here you will have a host machine. Okay, you will have a host machine, no difference in that. So you should need a hardware irrespective of what you are doing. Again, so this host can be a VM also. It's not like it needs to be a physical hardware. It can be a VM also. A VM also can be treated as a host. Any compute device you can take it. Okay, now instead of just occupying all of the resources, okay, uh, the containerization concept deals with something called as a process. So what happens is that every container, okay, so whatever container you have here, okay, so instead of just allocating everything and moving it out, so it is treated as a process. That's it, a single process. Okay, again, the features of this process is completely isolated. It doesn't have to do anything what's happening outside. There is no dedicated division. Okay, but it restricts, there is a restriction that it cannot access the outer environment. There is a lot of isolation, and the resources can be allocated based on demand. So how much resources you need to access all of this, and it will have its own file system. It is very much lightweight. Okay, because it's just a process, right? You need not to have a lot of things running on, so it's very much lightweight. You have the networking capabilities, so you can allocate resources, everything, but at a very lightweight manner. Okay, so this is what containerization is. Okay, I hope now you guys can give the differences, what is virtualization and what is containerization. Again, so let's look how this happens in the next section. Okay, now what is Docker? Docker is a tool which maintains this, how to spin up a container, okay, how to delete a container. So all of these tasks are done by Docker. That's it. Okay, Docker is just a tool to maintain this or manage this. Managing this containers, we use Docker. Okay, great. Now how Docker works? See, Docker, the main power of Docker is because of these three concepts. Okay, so one is namespace, next C groups, and you have UFS. Okay, not UFC, it's UFS. Now these are the components of the kernel. Again, if you see right here, each VM will have a kernel, but here each container will not have a kernel. There will be only one kernel. Okay, and each container will share it. Again, there might be multiple containers running, right? So it will share this kernel. Okay, making it very much lightweight. Kernel. Okay, again there won't be any okay, so there will be base image instead of dedicated OS. Now these three are the heroes who just didn't give the inception of Docker, but the whole concept of containerization. Again, let me give you a whole higher level explanation. Don't worry about everything. If you are interested, you can take it forward. But yeah, so on whole level, the isolation, I told you, right, isolation task, that one container should only use the resources of it. It should not indulge into any other process. Again, I told you, right, process. It should not get into the other process. So this capability is given by namespaces. Next, C groups are divisions. Okay, so how much resource to use, basically the access control, how much to use and who has the access to it. C groups gives it. And UF is union capable file system. Okay, so this gives you the capabilities of directory structures or the file system. Okay, because of these three superheroes, you can run a lightweight instance or a process which shares the kernel. So this is what is the main here. Here, each machine will have its own kernel. Like if you have three VMs, three kernels, but containers, only one kernel, it will be sharing it. Okay, all of the resources will be shared on demand. Okay, again, I have seen on a single VM, so we have like hundreds of containers running. It's not like just one container. Again, later on, what we see, Kubernetes, all of these will manage this container orchestration. Okay, we'll see that later. But yeah, Docker is the thing. So I hope you guys now know why should you use Docker, virtualization, containerization, Docker, and how Docker works. Now we'll come back to the problems. I told you, right, two problems of sharing and deployments. So that is where this Docker images, Docker container, and Docker registry come into picture. Now what happens is that whenever you have a project, okay, whenever you have a project, let's take this as a project. You have this project. It can be a web project, anything. So for that, you will write something called as a Docker file. Okay, Docker file is like a configuration file. It gives you a steps. Okay, like let's say simple Docker file. If you let's look at a simple Docker file. Okay, okay, let's take something like this, a simple node project. So it says that I need node, so it says that from node, what version to use, everything, and you can create folders. Again, I told you, right, it cannot access the host machine, so files should be copied into the container. Yeah, so that's why you see a lot of copy things, and you can run these commands, expose the ports, all of this. So this Docker file is set of instructions, each task what you were doing it manually, right? So for that you will write steps in the Docker file. Now this is the this will be in your project directory itself, which has access to all of these files as well. The files also should be there. So if it's like copy this, right, so the path will be relative to this Docker file. Now this is like the recipe book. Using this you can write build a lot of recipes. Okay, now using this Docker file, first you will generate something called as a Docker image. Okay, again, so there is a lot of advantage on this. Okay, Docker image. Now Docker image is like the compiled version. Okay, so it took all of the instructions and it built the project. Okay, if you don't want to share all of these resources, it's okay if you can just share the Docker image. Then you don't need your source code, your dependencies, your packages, anything. It's like the built version. Again, yeah, so this has the instructions for the recipe. So this is the ready-made recipe, instant recipe packet. Okay, it's like it has the recipe for Maggie. Okay, how to do it. And this is like the packet of Maggie what you get, which you can just get it done in 2 minutes. Okay, so this is the instant pack for the recipe. Now using this Docker image, you can spin up multiple containers. One image can spin up millions of containers. Okay, because you are just preparing it. It's like you have Maggie and you can do the same thing, right? 100 times. So you will run a Docker or a container. A container will be spinned up. Okay, now this is what is Docker file and Docker image. Using Docker image you can write the container. Docker file is the configuration, Docker image is the built version. Okay, which has all of the steps how to run, and if you just run that Docker image you will spin up the container. Now comes to the problem while sharing and deploying, right? Now either if you want you will share this project along with Docker file and they will build the image and they will set up the container. Same with deployment. Instead of setting up everything manually, they will run the Docker file, get the Docker image and build the container. Now if you want to share, you don't want to share all of this project source code, everything. You only want to share the image. Okay, they can spin up everything, that's it. So at that time you will push this to a Docker registry. This is like GitHub, okay, but for Docker images. Okay, Docker registry, or else let's not take this as a GitHub, like npm pip, whatever we have, right? Package managers. Similarly this registry will store all of the Docker images. Again, there are two types of registries. One is a private registry. Okay, means every company will maintain their private registry, and next there is a public registry called as Docker Hub. Okay, if you go to Docker Hub, right, you can see this is a container image library. So where you will find all of the containers which are public. Like let's say I want a node once. Okay, see Docker official images. So here we'll not have something called as versions, we'll have tags. This is the container name and these are the tags, 24 Alpine. Okay, these are the tags. Okay, and they have specific Docker file. See, if you go to node, they have Docker file for Alpine 3.1. For each version they will have the Docker file, and these are the images and we call this as tags. So this is a public registry, this is a private registry which companies opens. Now if you want you can share the source code, or else you can just say, hey, pull this image, and they can directly pull this image from the Docker registry and spin up containers. Okay, this makes the process more easier, right? You can avoid a lot of issues in sharing and deployment. Again, so it might look complex as of now, but trust me, it is very much simple. Let me share experience of my own. So when I was first building web projects, we were deploying at night and it was taking me around 1 hour. Okay, we were used to manually type all of the comments, and if one command is missed, so then I should go debug it, figure it out, do it multiple times. Again, the worst part is that I should do it multiple times, and the chances of failure are multiple times also, right? But here you write the Docker file once, and if it runs one time, you debug it one time if you have any errors, and next time it doesn't give you any error. Okay, if you're considering you didn't do any changes. So that's the whole advantage. So that's why go to any of the job descriptions, Docker will always be there. Now let's do a hands-on thing. So I will go to my machine. Okay, so again in the previous video we have set up this YouTube demo. Okay, just a minute. So let me restart this. Let me open Termius again for someone who is doing for the first time. don't worry. So this is what we have done in the previous video, so you'll have it in the pin. You can directly download, watch that video from there. So this is where it is. So we have the YouTube demo VM. So we have set up this VM onto the cloud, so we will be using this. So by default Docker is will not be there, so just search for Docker, and if Docker exists it will give you a version, or else you need to manually install it. So let's use the apt way. So you can just say this install docker.io, and your Docker will be ready to set up. Okay, so again I didn't update and upgrade this machine. It's a good practice to always update and upgrade whenever you have a fresh machine. Okay, great. So now whenever you just say Docker, it should give you telling that, hey, the Docker is set up. It should give you something instead of telling not found. That's it. Now I will just show you a simple one. So I will go here and search for hello world. Okay, so this would be the hello world, an example of mini Dockerization. Okay, so I will just say docker pull hello world. Okay, if you want you can specify the tags, or else it will take the latest ones. Okay, I'll just say sudo docker pull hello world. So with this it will use the default tag latest. Okay, see, this is using the latest tag. If you don't specify anything, it will use the latest ones, and it is pulling from the library. So where it is pulling from the Docker hub. Okay, if you haven't specified anything. Now like let's run sudo docker run, like let's say hello world. Okay, again there are a lot of modes, tags to do, but yeah, so the simple command is sudo docker run. So if you do this, so it gives you the telling that hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. The Docker client contacted daemon. Daemon pulled the hello world image from Docker hub. The daemon created a new container for this image. Stream the output to Docker client, which sent in your terminal. Okay, you can see this. It's basically it's pulling the container, and if you see this now, if you just want to see what are the images downloaded, you will just say sudo docker images. See, I have hello world with tag latest. Okay, and this was created 2 weeks ago, not in my machine, it was deployed 2 weeks ago. And now if you just say sudo docker ps, so I don't have any process running because this just dumped everything to the terminal, but you can run this run your applications as well, which you will see in sudo docker ps command. Okay, again the world of Docker is very much exciting. We'll explore one step at a time, but yeah, so this would be a great start for you to understand the whole ecosystem of Docker, how it works, and what are the advantages. And yeah, so that's it for this video. If you like this video, just give it a thumbs up, comment me if you have any questions. I would make sure everything would be answered. And yeah, finally share this with your friends so that even they start with their Docker journey. That's it, and I'll catch you up with the next one. Thank you guys.